Hello everyone, this is Sai Sri and welcome to my channel. So in this video, let us answer a question that is derive AV, which is nothing but voltage gain, EI, current gain, RI, input impedance, and R0, output admittance, AVS, voltage gain with source, AIS, with current gain with source in terms of H parameters of a transistor amplifier. So this is the H parameter of a transistor. So how we got this means I will make a separate video on this. I will drop the link below in the description. So this is the H parameter model of a transistor amplifier. So this is the basic one. So from this we can get two equations. They are V1 is equal to HI1 plus HRV2, and another equation is I2 equal to HFI1 plus H0 V2. So here V1 and V2 are the voltages and I1 and I2 are two currents of a port. So HI is current gain, HR is reverse voltage gain, HF is forward current gain, H0 is output impedance. So here it is input impedance. So how we got these equations? How do we know that HI is input impedance? All this I will make a video how we got this transistor H parameter model in a separate video. I will drop the link in description box. So here we have voltage source and it is resistance of the voltage which is in series with the voltage, and V1, V2 are the two voltages. HI is the input impedance, HR is reverse voltage gain, HF is forward current gain, and 1 by HOE is output admittance. If we write HOE, it is output impedance. If we write inverse of it, then it will become output impedance. So first one, let us find the current gain. So current gain A is equal to, what is the formula, is output current by input current. So here we have two currents, I1 and I2, which are entering into the port, and IL is the load current which is coming out of the port. So these two are in opposite direction. So I2 equal to minus IL. So this equation is very important in deriving this. So AI is equal to output current by input current. What is the output current? Here we have output current as IL. So IL by input current is I1. So I1. So IL is equal to minus I2. Minus I2 by I1. So from the basic equations, let us say this is equation number 1 and this is equation number 2. So from equation number 2 we have I2 equal to HF I1 plus H0 V2. So from these equations we can write I2 equal to HF I1 plus H0 V2. So in the place of V2 we can write, so what is the voltage formula? V is equal to I into R. So here V2 is equal to minus I2 into RL. So here we have load resistance RL. So IL into RL, whereas IL is equal to minus I2. So minus I2 into RL. So in place of V2 I am substituting minus I2 RL. Now I2 is equal to HF I1 plus H0 minus I2 RL. Now this one come this side, I2 plus H0 I2 R1 HF I1 common I2 1 plus H0 R1 is equal to HF I1. Now we want output current and input current. A is equal to minus I2 I1, right? So we want I2 by I1. So I2 by I1 is equal to HF by, here it is multiplying, so here it will become division, 1 plus H0 RL. So this is H2 by I2 by I1, but actually we want IL by I1. For current gain we want AI is equal to IL by I1. So we have to write minus. So I2 by I1 is equal to minus HF by 1 plus H0 RL. So this is equal to AI. So current gain AI is equal to minus HF by 1 plus H0 RL. So the next one is the voltage gain. Voltage gain is represented as AV. AV is equal to output voltage by input voltage. What is the output voltage? V2. And the input voltage is V1. We already know that V2 is equal to minus I2 RL. So here we have written while finding current gain. So that is minus I2 RL by V1. So the AV is equal to divide minus I2 RL by V1. Now divide both numerator and denominator with I1. Then what we get? AV is equal to minus I2 by I1 into RL by V1 by I1. So that is equal to, what is minus I2 by I1? That is equal to AI. So in place of minus I2 by I1, I am writing AI RL by V1 by I1. So this is nothing but input impedance ZI or RI. In some textbooks it is given as RI, in some textbooks it is given as ZI. Both are same, both are input impedances. So in place of V1 by I1, I am writing ZI, or you can write RI also. So AV is equal to AI RL by ZI. Now let's find the input impedance. So here I am writing ZI, you can also write RI. So from voltage gain I have taken ZI, so at the end of the derivation I will use only ZI. Use either ZI or RI, don't use both. So what is the formula of input impedance? V by R, V by I, RI or ZI. So that is equal to V by I. So V input impedance, so we have to take input side voltage and the current. So V1 by I1. So from the basic two equations which we have written at the beginning, so V1 is equal to HI I1 plus HR V2 from 1. So now substitute this V1 here. HI I1 plus HR V2 by I1. So we already know that V2 is equal to minus I2 RL. Substitute in place of V2. HI I1 plus HR minus I2 RL by I1. Now the equation becomes HI I1 by I1 plus HR minus I2 RL by I1. Just I am splitting the terms. So I1 cancel, HI plus HR minus I2 by I1 is equal to AI. So in place of this I am writing AI RL. Now ZI is equal to HI plus HR. We already know the value of AI. So in the current gain we got AI is equal to minus HF HR by 1 plus H naught RL. So substitute that value, minus HF A value is minus HF 1 plus H naught RL into RL. So from this HI minus HR HF, here I am taking RL common. So when we take RL common, it will become 1 by RL plus H naught. RL get cancelled. HI minus HR RF. Let us assume that 1 by RL is equal to GL. Then it will become GL plus H naught. So this is the formula of input impedance. Similarly, we can find the output admittance also. As we are finding the output admittance, which is nothing but inverse of the output impedance, so we have to take 1 by HOE. So if it is the emitter configuration, we take E. If it is the base configuration, we take B. If it is collector configuration, we have to take subscript as C. Just we have to change the only subscript. Remaining formulas are same. So for example, it is emitter configuration, then we have to say ZI is equal to HIE, HRE, RF plus ZL plus HOE. Just we have to change the subscript. That's it. Remaining process is same formulas we have to write. So for the output admittance, we have to take the output voltage and the current. So as it is a admittance, for example, we take for Z out we will write V2 by I2. So as it is a admittance, we will write I2 by V2. So Z naught is equal to I naught by V2. So this is the output admittance formula. Z naught is equal to I2 by V2. So we know the from formula equation 2 we have from equation 2 I2 is equal to HF I1 plus H naught V2. So substitute I2 value here. So Z naught is equal to HF I1 plus H naught V2 divided by V2. Z naught is equal to HF I1 V2 by, just split the terms, HF I1 by V2 plus H naught V2 by V2. Then V2 get cancelled. So H naught. Let it be equation number 1. Now from the circuit, let us see the circuit. If we write the KVL to the input side, then the equation becomes KVL. We have to add all the voltages. Here we have I1 current and the voltage. So here we can write the source voltage is Vs. So the overall voltage is equal to Vs. So Vs is equal to Rs into I1 plus Hi is also a resistance. So Hi into I1 plus HR into V2. So this is the KVL formula which is useful in finding the output admittance. So the formula becomes Vs is equal to Rs I1 plus Hi I1 plus HR V2. So from this equation, let us assume that Vs equal to 0. So then the equation will become Rs I1 plus Hi I1 plus HR V2 equal to 0. Common I1. I1 is equal to Rs plus Hi plus HR V2 equal to 0. Send this HR into opposite side. So then the equation becomes minus HR V2. Now we want I2 by V2. So I1 by, just send V to this side, it will divide, minus HR, send this Rs plus HA this side, so it will do division. So we got I1 by V2 is equal to minus HR by Rs plus HA. So from equation 1, here we have I1 by V2. So from 1, we have Z naught is equal to HF. So substitute the value here. HR Rs plus Hi plus H naught. So from this, HF minus HR Rs plus Hi plus H naught. So this is the output admittance equation. So up to now we found current gain, voltage gain, output admittance, input impedance. So these are the 4 derivations mostly asked in the examination. There are 2 more derivations, that is voltage gain with source resistance and current gain with source resistance. So let us see the AVS, that is voltage gain with source resistance. So in order to find the voltage gain with the source resistance AVS, just we have to take the Thevenin's equivalent of the circuit, that is input side part. So let's see the H parameter circuit once. So this is the H parameter circuit we have. So this circuit, this part we have to take, only this part we have to take in order to find the AVS, voltage gain with voltage source. So I just take only voltage source Rs, V1 and Hi, and I will find the voltage gain with the source resistance. With the source resistance I will find. So here I took the input part. So just I have drawn a resistor in place of Zi. So this is the Thevenin's equivalent circuit. So from this, I can write this as V2 by Vs into V1 by V1. Just I am multiplying and dividing V1. Now AVS is equal to V2 by Vs into V1 by V1. So just I am writing V2 by V1 into V1 by Vs. So what is V2 by V1? V2 by V1 is equal to AV. So AV into V1 by Vs. So this is AVS. So we can also write by using H parameter equations, that is just write the KVL to this circuit, that is minus Vs plus I1 current is flowing, I1 RS plus I1 ZI is equal to 0. So from this equation we can write, taking I1 common, RS plus ZI is equal to Vs. So I1 is equal to Vs by RS plus ZI. So this is nothing but I1 is equal to Vs by total resistances RS plus ZI. From Ohm's law we have Vi is equal to I1 ZI. From voltage division law, if you don't know what is meant by voltage division law, just watch a video. I will drop the link in the description box or I will pin in the comment box. So from voltage division law we can write V1 is equal to total voltage source Vs into where we have to find voltage at ZI by RS plus ZI. So this is the V1 value. Just substitute this value here in equation number 2. Substitute this value in equation number 2. So by substituting we can get AVS is equal to AV into Vs into ZI by RS plus ZI, and this Vs will become 1 by Vs. Now AVS is equal to AV, Vs get cancelled, ZI by RS plus ZI. So this is voltage gain with resistance. Now let's find the current gain with the source resistance. Just we have to convert the input side into Norton's equivalent. We have from the source transformation in network theory we can find the Thevenin's equivalent into Norton's equivalent. So I am converting the Thevenin's equivalent into Norton's equivalent by putting a current source parallel to the resistance, that is RS and ZI. So according to source transformation, we can convert this voltage source into current source by connecting parallel to the current source. So these two are equal according to source transformation. So same formula I have applied to the input side. So from this AIS is equal to, what is source gain? IL into, so in previous case we have taken IL into I1. There I1 is the current. So here we have IS. Just multiply and divide with I1. So here IL is equal to minus I2 by I1. Minus I2 by I1 is equal to AI, that is current gain, which we got previously in the starting point. At current gain we got minus I2 by I1 is equal to I1. So that value I am substituting here. So from this, so here we have to apply current division law. So I have also made a video on current division law. So how to write that equation. So I will drop that link also in the description box and I will pin in the comment box. So I1. So for I1 I am writing the current division law. So here we are finding the I1 at ZI, at RS and ZI. So the current division law will become the total current source is IS into, at what we are finding the I1 at source resistance, at R we are finding. So we have to take the opposite resistance. What is the opposite resistance? We have ZI. So in the voltage law we will take the resistance where we are finding the voltage, but in the current division law we will take the opposite resistance in order to find the current at that resistance. So here I1 is equal to this one. So substitute this formula here. IS get cancelled. So this is RS. So this is current gain with source resistance.